taxing on my old computer here. Okay, so hello everyone. My name is Alex Garcia. This is a sqlite-vec online event hosted in the Mozilla AI Discord channel. I try to do these about once every month. I've only done one before. That one was the launch party for sqlite-vec when v0.1 came out about a month ago. There we talked about sqlite-vec in general, what it means, kind of like some code samples of how it goes. And what I want to do in this event is talk about two specific things with sqlite-vec. The first one that we're going to talk about is mobile device support. So we have experimental and work-in-progress bindings for Android and iOS. So you could run sqlite-vec natively on those devices. It's still a work in progress, but I have a little demo to show you all if you're interested in to see how that goes. Currently, sqlite-vec runs on command line interfaces on your Mac, on your desktop, laptop, computers, and such. So doing that on mobile devices kind of unlocks some new potential, which we'll talk about today, and we'll have some demonstrations there. Additionally, we're going to talk about binary quantization. It is a method of reducing the size of your vector index. So typically when you have a lot of vectors, it can add up. A lot of disk space, a lot of memory is needed. And one approach to make that a little bit easier that sqlite-vec supports is something called binary quantization. It can reduce storage costs for vectors up to 32 times. So if you have a 32 gigabyte vector index, you could possibly reduce that to 1 gigabyte. There are some trade-offs there, like accuracy won't be as good, but if you choose the right embeddings model and try a few different tricks, it might be good enough for whatever your applications are. So again, those are the two topics we'll talk about today, mobile devices and binary quantization. I might also talk a little bit about sqlite-vec in general and some projects and some features ideas that I have. Not much has changed. Not many new features have been included since the initial release from a month ago. But I definitely have a lot of plans for new features and new things to include inside the library itself. So if you want to talk about that towards the end, more than happy to do so. And like I said before, if you have any questions during this time, feel free to drop it in the Discord chat. My speaker isn't quite working, so if you get on stage and say something, I may not hear it. So just be sure to leave it in the message, and I'll catch it. Also, if at any point you can't see anything, if the code is a little bit too small, if the terminal is a little bit weird or whatever, again, feel free to drop it in the chat, and I will try to attend to it. Right. Another thing. So before. A few minutes ago, I'll repost it in the chat, but let me just copy and paste the link. So there is a link in the chat. It is a Google Doc that has links to all the stuff that I'll be talking about today. So all the pull requests, all the feature ideas, all the notebooks and code samples, it will all be there. And eventually, when this is recorded and put online, a link to the recording will be put there as well as any other links that pertain to this event. There's also a link in that Google Doc to the previous event's Google Doc that has links to those if you're interested in exploring what we talked about last time. So be sure to check that out, bookmark it, share with your friends, do whatever you like. All right. So let's talk about mobile support. So I'm going to switch my screen real quick to another tab. Just bear with me for 1 second. Just switching my tabs real quick. Apologies if this takes a second. This will be going into Chrome. Trying to switch to Chrome. Please. OBS. Sorry, 1 second. I'm just trying to switch my screen into a different one so that way you all can see what I'm seeing. Window capture, Figma. OBS, Figma, binary. Okay, application capture. Cool. And then application, Chrome. Perfect. Okay, so currently sqlite-vec has only worked on, oh wow, let me adjust the window screen so that way you could actually see what I'm seeing. There we go. My apologies. There we go. Okay, so currently sqlite-vec has been mainly for usage in servers on the command line on your laptop, whether that's Mac OS, Linux, Windows. It's all been supported before. However, one big goal that I have is that since sqlite-vec is written in pure C with no dependencies, it can theoretically run in other environments, right? So the initial cool environment that I had before, that we demonstrated when sqlite-vec first came out, was WebAssembly, so running it inside the browser. Since it's written completely in C, you could use a tool like mscripten to compile that C into WebAssembly and also link together with SQLite WebAssembly libraries that currently exist. And you could have SQLite-vec or vector search in the browser. And that was a different environment than the typical server or command line interface that you had to try out SQLite-vec or to do vector search. And I've been wanting to do mobile support, so Android and iOS, for quite some time. I am not a mobile developer. I tried it once in college, and it was quite a nightmare, especially back then. So I have not touched React Native or anything like that in quite some time. However, the maintainer of the OP SQLite project reached out and kind of helped me out with some of the initial bindings for SQLite-vec into Android and iOS. If you're not familiar with what OP SQLite is, there is a link to in the Google Doc to the OP SQLite project. But this is a React Native library for SQLite. So it is extremely fast. It can, it runs natively on your phone. So in Android, it'll compile it and use it within the, weird Java Kotlin runtime that's available there and expose in React Native for JavaScript. Same thing with iOS. It binds to whatever weird C#, whatever's in there. It's a SQLite library for React Native, for JavaScript that runs on iOS and Android. It already contains a few other SQLite extensions. So if you're familiar with CR SQLite, which is a conflict-free resolution, a SQLite extension where you can kind of sync different tables and data sources together, that is already available in OP SQLite. And they recently added support for SQLite-vec as well. And I'll do a quick demonstration of what that looks like. So I will switch my screen over to another VS Code tab. So bear with me for another 30 seconds while I figure this out. Let me go to window capture and change it over to VS Code. Perfect. So this right here is a bare bones example of code of SQLite-vec running within OP SQLite in React Native that could be ran on mobile devices. So it's fairly straightforward. Bear in mind, I am terrible at React Native because I have never done this before. And mobile development in general scares me, but this is in general what it looks like. So we have inside of this OP SQLite project, which if you're interested in how this actually works, I would consult the OP SQLite docs. There's a link to a Notion document that talks about how to install and run OP SQLite on React Native and how that kind of works. But essentially, the way that you enable SQLite-vec inside of OP SQLite is inside of your package.json. You have a very specific block right here called OP SQLite, where in this case, you get to define a few feature flags, where one of them is the SQLite-vec true flag. And when that's on, when it builds and bundles SQLite into your application, it will bundle SQLite-vec inside of there. So as an example of how that works or how it looks like when it's running, I have a little simulator here. So I will again switch my screen over to that, which will again take 30 seconds or more. I'll switch this over to the simulator. Cool. So this is a simulator that's running iOS on a simulated iPhone 15 on my Mac that I'm running right now. Not a lot to see, but it is running the React Native JavaScript code that I showed earlier. So you can see this right here, this version string, this v0.1.2 alpha 7. That is the version of SQLite-vec that is running. The way that it did that was that it executed SQL that called the vec version SQL function that's available in SQLite-vec. And there we go. That's the exact version of SQLite-vec that is running. And here is, and right below that, this vec distance L2 thing. This is a very bare bones example of vector similarity calculations and using SQLite-vec. So again, this is running SQL that's calling SQLite-vec functions and returning, vector search operations. So just a very, very quick hello world example of SQLite-vec running on a mobile device. Now this is a simulator, so this is an iPhone 15 that's running on my, a simulated iPhone 15 that's running on my Mac. If I actually want to run it on a real device, since this is React Native, it also runs on Android. So I could also run it on my Android phone that I have right over here. Where'd it go? So here, I have my old Android phone that I'm using. What I will do to demonstrate how this works is I will switch the screen over to, I'm going to switch this back over to VS Code so you can kind of see how this works. So this is back to the code for React Native OP SQLite that's running SQLite-vec. These are the logs of running the application and the React Native stuff running and running this on the simulator. And what I can do is I can tell it to open this on my Android device that I have. And let's see if it works. There we go. So now this is my Android phone, my old Android phone that I have, running the React Native application that has sqlite-vec inside using OP SQLite, compiled to an Android application that's running on my phone, wired into my development machine. So same screen as we had before, but instead of simulation, it's a physical device. So here we can see the vec version string, the vector calculations, all happening on my phone. So this isn't happening like on my Mac and somewhere else. This is like compiled to my phone, running on this device, running just fine. If I was a better mobile developer, this would work. I could, bundle an application, run it on my phone, completely disconnected from the internet. I could run other models on my phone as well. If you're not familiar with llama.cpp, that runs different embeddings models on device on your CPU, which could run on Android devices as well. I believe LlamaFile, which is another Mozilla AI Builders project that runs different large language models and embeddings models. It also has Android support. So I believe it runs just straight out of the box. You don't have to change anything because it's a single file that runs everywhere. I believe you could run that on Android and use SQLite-vec all on the phone. No wires connected, no internet needed, just all running natively on your own mobile devices, which is really cool. I see some people in the comments talking about Flutter. I believe it will work with Flutter. Again, mobile development is not my thing, so I'm not entirely sure how it works. But someone did, when SQLite-vec initially came out, someone was able to run Flutter macOS applications just fine using it, and we were able to get it to work in WebAssembly. Oh, the person is here who did that. Awesome. Yeah, again, thank you for that example. I just haven't done it again. I just haven't taken a look at it because I am not a great mobile developer. But from what I remember, Flutter WebAssembly was able to work with a few tweaks that we made. So I believe with these new iOS and Android bindings, we could also bring it into Flutter projects, and it should just work out of the box. That way you could have the same vector search, the same vector SQLite database, and run it across, WebAssembly, Android, iOS, Mac OS applications, all in the same code base, all using Flutter, which is really cool. So hopefully in the next few weeks, or I think in the next week or so, I should have these bindings officially available and downloadable in the SQLite-vec project. I will have pre-compiled SQLite extensions for Android platforms. I believe that includes ARM, x86, and some other weird processor. I should have those available on GitHub releases if you just want to download it directly and run it. And it will be available in OP SQLite as well if you're using React Native. If you want other types of bindings for mobile devices for SQLite-vec, again, I'm not a mobile developer. I would love your help on how I can make that a little bit better. I know there's something that I could do with Java packages or Java packages for Android or Swift packages for iOS. I'm not 100% sure because I don't really know how it works. But if you have any idea of how to, if you have any feedback of how we can make that better or easier to run on whatever mobile device platform that you have, happy to do that as well. Oh, and the thing about SQLite REmbed, yeah, I did add it. I just added a license to that a few days ago. I just haven't made a new release for it yet. But yeah, I did see your comment, so there is a license for that. It's MIT Apache 2, so there should be no problem with making contributions there. And I'll happy to merge in any Google embedding stuff that you're able to put in there. So again, OP SQLite is a React Native library for running SQLite within React Native applications, including Android and iOS. And there's now a feature flag within there for experimental support for SQLite-vec, which is now available, and you can run it yourself. I'll try to share the code that I have, although it's not that pretty. And honestly, the OP SQLite documentation goes over it much better on how you could actually do this yourself. And within the next few days, we'll have official bindings for this up on the SQLite-vec GitHub repository inside of the releases that you could download. And they should be able to work right out of the box, just like that. So big developments within mobile devices support with SQLite-vec. Additionally, in addition to Android and iOS devices, let me change my screen real quick. So in addition to Android and iOS devices, SQLite-vec as a purely written in C, no dependencies thing, also runs on other devices. Raspberry Pis are one of them. So if you can SSH into a Raspberry Pi and run your applications and run some code there, you are able to compile SQLite-vec into a extension that runs on Raspberry Pis. One example of that is I have this little device right here. This is called a Beepy, or I believe it was initially called a BeepBerry. It is a Raspberry Pi W02, I believe, that is running, it has a built-in battery inside, so there's no wires, no connection needed. It has a e-ink display that can run terminal applications, so TUI applications, and also comes with a cool little BlackBerry keyboard, refurbished keyboard that you can use. So this is a small device, again, Raspberry Pi, not connected to anything, doesn't even need Wi-Fi if you don't really require it. And this can also run sqlite-vec. So an example of how that works. Let me just clear out of the previous demo that I had. So what I have here is, again, this is the terminal. It has I built a little TUI that does a semantic search example, right? So this is running a Python application, and you could barely see it. To be honest, the screen isn't that great. I would say that this entire setup was very cheap, and I believe they're going to be selling new versions of these relatively soon. The company that made this was, I believe, called something like sqlite. I'll drop a link in the Google Doc once I really find it. If you look up Beepy or Beatberry, it should appear. I don't think they're selling any devices right now, but they should be selling some in the next few weeks. But essentially what I have is a Python application, and you can see just barely, if the screen focuses, there's small text that says enter your query, right? So what I can do is I can type out something like climate change. And what is happening here is that I have a small data set of news applications, of news headlines from a source from a newspaper, right? So news headlines like, Kamala Harris drops out of the race, or, things like that. And I have a local embeddings model running on this device using SQLite lembed. Lembed is a sister project of sqlite-vec. It can run local embeddings models using llama.cpp. That is running on here, and also has a SQLite database of these news article headlines with embeddings pre-computed. And what I could do is have a little Python application that takes in a query, finds the 10 closest news articles, comparing the headlines to the query that I had, and it'll return a nice little table of results right there. And again, this is all happening all local. There's no outside connection happening. The model itself is running on this device. The vector database is just a single SQLite database that's on this device as well. And the queries that I make is all on this keyboard. So there is no internet connection needed for this. It is all running on one single process, so there's no separate server or anything. I could disconnect this from the internet if I wanted to, and it would work just fine. The actual specs on this thing it's very lightweight. I think it's like less than 200 or 500 megabytes of RAM. The file system is a SD card that I had that I think was in my old Switch. And the battery lasts I think 2 hours or so. So again, vector search all happening on this device, no extra server needed, just happening on this little Raspberry Pi device that I have. And that's one big goal that I have for SQLite-vec. I want it to run everywhere. I don't want users to have to be able to have a GPU to run this stuff, or a big computer, or a lot of memory or RAM. In this case, the SQLite database is on disk, so on every search, it is searching through the file itself. It doesn't load in a lot of memory all at once. It doesn't load the entire data, the entire vector index into memory, which is very great for usage consumption. So again, it's light. SQLite-vec is light enough to run on this little device with no internet, with less than 500 megabytes of RAM, and it's pretty quick with it. So again, that's how it looks like using this little screen device here. So mobile device support and SQLite-vec just getting better and better every single day. So what I want to talk about next is something called binary quantization. So before we were talking about SQLite-vec running on new platforms, on new devices, which is great, Android, iOS, Raspberry Pis. But another technique that I want to talk about is something called binary quantization. And one way that I want to demonstrate of how of what this technique does to make large data sets easier to run on smaller devices, including mobile devices, is I will switch my screen over to. I'm just going to switch my screen real quick, back over to the presentation. Perfect. So one thing with vector databases is that this data can get quite large, right? You have some database with text in it, right? Whether it's like news headlines or comments on a YouTube video or comments on a news article or something, right? You already have your text database, and you have to, given text, generate embeddings for every single row inside of your database. And this can add up quite a lot. For example, Here, let's say we have a table with 1 million rows, which means we have 1 million embeddings per text item inside of that database. So 1 million embeddings. Not a lot on most databases. SQLite can run queries on 1 million row tables just fine. This is maybe like a couple dozen to a couple hundred megabytes of disk space, so it's quite easy to go through. However, if you're using if you're wanting to perform vector search on this, 1 million embeddings can add up in disk space quite fast. So let's say that your embeddings models uses 3072 dimensions. This is not normal. Most embeddings models are quite smaller than that. For example, some of the very small ones are like 368 dimensions. The good ones are like typically 700 to 1024 dimensions. So they're usually quite smaller than 3000 dimensions. The only reason why I'm using 3000 dimensions here is because that is the size of the largest embeddings model provided by OpenAI. The OpenAI text large number 3 embeddings model has 3000 dimensions, which honestly is overkill for most applications, but if you need it, it's 3000 dimensions. And if you were to store 1 million of those embeddings at 3000 dimensions with 4 bytes per float, which is the size of a floating point number on disk, that's going to be 12 gigabytes of space just for your embeddings, right? So you went from a table with 1 million rows, which again is like maybe a couple hundred megabytes, depending on how big the text is. Usually pretty manageable with using SQLite or smaller device or other like smaller similar tables or similar database management systems. But if you want to have embeddings on that, using this large embeddings model, that's 12 gigabytes of extra space that you need. I would say that most other vector search solutions, they will store all this within memory. So this is what Feist does, and this is what some of the other low-level vector search libraries do. And 12 gigabytes of memory is just not possible on most devices, right? The Mac that I've been developing on for the past 5 years, the old Intel one, I think has like 8 gigabytes of RAM if I'm lucky. So that's already going to I'm already going to become out of memory if I try running vector search all in RAM using a vector data set of this size. So there's a lot of different methods or techniques that people have to reduce the size of their vector index. There's scalar quantization, there's matryoshka embeddings. There's many different ways on how to do this. You could also build your own index or like train your model to output smaller dimensions. So there's a lot of like complex ways of handling or reducing the size of this vector index to something more manageable, right? But I'd say binary quantization, which is the second topic for today, is a very easy method that works very well and has some trade-offs, but it might be just fine for whatever your use case is. So what binary quantization does is that instead of needing 4 bytes per floating point number inside of your vectors, for each embedding, instead of 4 bytes per float, we instead just need 1 bit. Usually these floating point numbers are some number between 1 and -1, right? So a single number inside of an embedding could be like, negative 0.68 or positive 0.42, something like that, right? And there's 3,000 of them per vector for your entire data set. And that's 4 bytes of data, so it's quite large. So what we can instead do with binary quantization is that for every single number, instead of storing this 4-byte floating point number where it's a number between 1 and -1, we instead convert it to a single bit. So if it's a positive number, so if it's positive 0.42, we're going to give that a 1. And if it's a negative number, like negative 0.68, we're going to give that a 0. So we have a bunch of 1s and 0s instead, which is way more compact, right? So instead of a 32-bit floating point number, we just have a 1-bit number. So that's already a 32 times reduction in size. And then with those 0s and 1s, instead of using something like cosine distance or L2 distance to calculate similarities between these vectors, we can instead use Hamming distance. So what Hamming distance is that it compares, given two vectors, it compares the 0s and 1s. And if if you're looking element-wise, so like element per element, if the first vector is a 1 and the second vector is a 1, that's higher similarity, right? Or if the first vector is 0 and if the second element is 0 and the other element is also 0, that's also higher similarity. So it's a similarity method for vector search that's looking at individual bits instead of floating point number bytes, instead of floating point numbers, which is much faster, way less memory usage, and way easier to manage. So as an example of the savings that you get from this, so the previous example that we had with 1 million embeddings, 3,000 dimensions each, at 4 bytes per float, well, that's 12 gigabytes of disk space that is needed. If we instead do binary quantization on that and reduce it by 32 times, now we have a 384 megabyte vector index, which is way smaller, way easier to work with. Most computers, including this little device that I have here, could fit that in memory if they really wanted to, although you could store on disk just fine. It's way easier to manage. Now, the problem with this is that there is some accuracy loss within that, because again, you're going from something that has 32 bits of precision into one, so you are going to lose some accuracy over this. But I would say most of the time you may not even notice, or it may be acceptable, right? So, for example, if you're building like a semantic search thing where you want you want fuzzy search over news articles of the past 10 years, it's okay to have like some accuracy loss, right? Like if some of the items that are returned in your semantic search thing are just some of the items are just re-ranked differently, that's probably fine. Or if you're supposed to get these 10 articles back and you only get 8 or 9 of them, it's probably fine. You're just doing you just have like a search engine that kind of makes working with these large data sets easier, right? If you're working on the medical field and you're trying to classify medical scans, and you're trying to classify whether or not it has a disease or not, you probably don't want to lose that accuracy. You probably want to keep as much accuracy as possible, so don't use binary quantization in those high risk areas. But a lot of the times you don't really need that. I would say a lot of RAG applications, so retrieval augmented generation applications, where you use an LLM to assist, where you use a vector search solution to assist a AI LLM to answer questions about a private data set. You also probably don't need 100% accuracy there as well. So something like binary quantization can make your queries faster, make things a lot simpler, and just kind of make your life easier in general. So binary quantization is a technique supported in SQLite-vec, and I'll go over some code samples of how that looks like, that you should consider if you're building some semantic search or other vector search applications in your projects. So I'm just going to go over comments real quick just in case. Onyx runtime Gen AI, please do. Out of memory, can you confirm SQLite-vec can do vector search that's bigger than phone memory? In other words, batching the work or splitting the storage. So question is, can SQLite-vec, if you have a vector search index that is larger than memory, will it work? Yes, it will. So if you're storing your vectors inside of a SQLite database, the vector search queries, the KNN queries, don't read the entire vector index into memory. It will do chunks at a time, and that chunks is configurable. That part isn't really documented yet. I think at most, depending on the number of dimensions your vectors has, it's maybe a few megabytes of memory that are needed to scan through all your data. So it'll only read a chunk of like 5 megabytes of data, of vectors, and then it'll move on to the next one and the next one. It doesn't read the entire thing into memory, so that should also work on phones as well. So if you have a very large SQLite database on a phone that's much larger than the available amount of memory that you have, it should still work just fine. It will be slower. It is, of course, always faster to have things in memory. So if you have a data set that's larger than memory, it will be slower to query, especially if it's way bigger than the available RAM that you have. But it should be acceptable depending on the constraints that you have in your applications. So I have a sample of what this binary quantization could look like. I'm going to again change my screen. Let's change this over to Chrome. Oh, perfect. Cool. So as an example of what binary quantization can help with is I am going to open up the Discord thing. Let me close my other tabs. So as an example of what this looks like, this is an example of a embeddings dataset that Superbase had open source in one of their projects, right? So they were experimenting with Matryoshka embeddings, which is another quantization technique that's kind of related to all this. But Superbase in general has this dataset available on Hugging Face, and what this is, it is 1 million rows from a Wikipedia dataset where they have embeddings for every single row inside of this. So for example, here we have the Wikipedia page for Ian Botham, and there is the title of the Wikipedia page and a quick snippet of the article itself. And they embedded that small snippet using OpenAI's large embeddings model, right? So they have 1 million rows of this, of embeddings that are 3,072 dimensions each. In total, if you were to download this directly, this is on Hugging Face in the Parquet files, this is probably going to be like 15 gigabytes worth of data, which is quite a lot, right? Like 15 gigabytes is like, takes a little bit longer to upload. It doesn't compress very well because embeddings themselves don't compress very well because they're usually pretty random data. So no matter what, if you're going to use the full 3,072 dimensions floating point, it's going to be 12 gigabytes worth of data to work through, which is quite a lot. So what we're going to do is we're going to take this data set, this 1 million, 15 gigabytes data, 1 million rows, 15 gigabytes data set. We're going to quantize it into bit vectors using this binary quantization technique. I'm going to show how well it runs on my laptop, how fast it runs, and how it's even small enough to run on this little device right here, okay? So the way I did this was, again, links to this data set and to everything else are available in the Google Doc that was shared in the chat a little bit earlier. I'll be sure to share it again in the chat because you might scroll up a little bit. So the way that I did this, the way that I was able to use binary quantization to run this application is here. I have a Google notebook. I have a Jupyter notebook. I will try to make this a little bit bigger so that way you can see. Cool. So I have a Jupyter notebook here that goes over how to download this data set from Hugging Face and how to use binary quantization using SQLite-vec to make it a much smaller SQLite database file. All right. So in this case, the exact methods of how to download this data set and how to like run binary quantization, whatever, it's not that important. There's a lot of different ways to download a Parquet file and convert it into SQLite. The way I did this for this Google notebook specifically was I used DuckDB. DuckDB is a tool that does many useful things, but one thing that it does is that it's able to read from Parquet files hosted on a different server, and it's able to insert that data into a SQLite database. So that's what we're going to be using DuckDB for in this specific example. So what we do using DuckDB is that we could read these Parquet files directly from Hugging Face using this HF prefix right here. We could read in every single row inside of these Parquet files, which again, there are 1 million rows. And we can specifically serialize these embeddings as a compact blob format that SQLite expects and insert it directly into a SQLite database. So in this case right here, we are creating a SQLite database called target.db, and we are inserting a new table that contains all the data from this Parquet file. So the ID, the title, the text, and then the embeddings themselves stored in a compact blob format. Now, once we have that inside of this target.db file, this is going to be a very large file, right? This is like 15 gigabytes in 15 gigabyte SQLite database file. Now, what we could do is we're going to create a copy of that database, this time called output.db, and we're going to attach the previous one, so attach the source database, the 15 gigabyte one we just made, and we're going to create a new table that has the same exact column. So we're going to copy over the ID column, the title column, the contents column. But instead of copying over the full embeddings column, which again is going to take around 12 gigabytes worth of space with the 3072 dimensional floating point array, we're instead going to quantize it into a bit vector using this SQL function called vec quantize binary. Again, this is part of SQLite-vec, so if you're using SQLite-vec, you'll have access to this SQL function. And what this vec quantize binary function does is that given the vector, so in this case, given each of the 1 million vectors inside of this database, it will go through every single element, every single floating point element, and if that element is positive, it will give it a 1, and if it's negative, it will give it a 0. And it will create a compact bit vector of that embedding, so a different representation using binary quantization, which again is 32 times smaller than the original vector itself. So binary quantization in SQLite-vec is all of a matter of a single SQL function, vec quantize binary. That's all you need. You don't need any extra configuration or whatever. It is just a single SQL function that you can call from any of your code samples. Now, once we have that, as an example of what that output looks like, so here we're just going to take a look at the ID column and how big the embeddings column is. So here we have, as we expect, the same title and ID that we had before, Ian Botham. The length of the embeddings column, it says 384 in here, but remember, this is the length of the byte of the compact vector. This embedding right here is a bit vector with 3072 dimensions, but a bit vector with 3072 dimensions only takes 1/8 of the space. Right? So since every single element is a bit, once you compact that together into a compact blob format, that only takes 3072 divided by 8 bytes of data, which is 384. So take this, multiply it by 8 because there's 8 bits in a byte, and now get the final 3072 dimensions vector that we expect from this very much smaller SQLite database that we're outputting here, right? So again, we went from a very large 1 million row data set with 15 gigabytes worth of data, 3072 dimensions and floating point numbers, and we're able to reduce it down to a much smaller database that is around, I think it's around like 500 megabytes for all this, including text and including embeddings. So much smaller, much easier to deal with, and now we could run it in different places, which I will demonstrate now. So here, I'm going to switch my screen again because I love OBS. So now I'm going to switch over to some code that I have. There we go. So this is, so what I have here, actually I could just show you. What was the name of it? Sorry, I'm just going to try to get my footing real quick. Okay, so DB. So here we have, I downloaded the SQLite database onto my Mac. It is called dbpedia opt for optimized. It is a 568 megabyte file that is on my Mac. This is much smaller than the original 15 gigabytes that we were using. So what I have is a quick little Python demo, similar to the one that I had on here. So what this does is that I can enter a query like climate change. And here, since the embeddings generator is from OpenAI, I am again using OpenAI's API to embed the query that I have and then commit and then do a KNN search on the 1 million vectors that I have on the SQLite database. Again, this doesn't mean that the embeddings are running on my computer. It's still an HTTP request to OpenAI because this original data set is from the OpenAI's embeddings. So it's not completely local, but it's mostly local, right? I have 1 million embeddings in this 500 megabyte SQLite file, and I'm able to perform searches on it quite fast, right? So there, the results that I have to do with climate change. Or if I look up Parks and Rec actress, I will again wait a few seconds to embed the query itself and then do the KNN search across the 1 million rows, and I get back Rashida Jones, who I believe was an actress on the Parks and Rec TV show. I believe that's true. And same thing as Nick Offerman, also another Nick Offerman, an actor on the Parks and Rec show, Adam Scott, Amy Poehler. So the same thing. So very, very good results using binary quantization. We did lose some accuracy, so I'm sure if you did the same search on the full, 372 dimensional floating point vectors, I'm sure the results might be a little bit better, depending on what better means, but we still get good enough results for all this. So instead of having to lug around a 15 gigabyte SQLite database file with all the data that I need, you can use binary quantization to make it much smaller, and it runs on my Mac just fine. I can also run it on this device that I have here. So I have a separate demo that I will pull up here where very similar to the one that we just saw running on my Mac. So it's the same Python application, same SQLite database, and same embeddings model. So this is now actually talking to the internet. It's not running the embeddings model on here locally, because again, we're using OpenAI because that's what the data set had. But what this can do is that I can again type out a query like climate change. I could type that out. This will make a request to OpenAI. It will embed the query that I gave it. And with that query embedding, it will search it on the binary quantized data set that I have that is sitting on this device. And it's running, searching through a million of those embeddings and trying to figure out, doing the same exact search that I had on my Mac, but running on this device. I would say that this is very slow, mostly because I haven't optimized binary quantization yet on it within sqlite-vec, so it's using some slightly unoptimized CPU instructions instead of really fast ones that are available now. But I would also say that Raspberry Pis themselves are also fairly slow, especially when it's a very large file like this one is. So it will take a few seconds in order for the query to actually go through, but it will go through eventually. And again, this is running on this device, something that like a 15 gigabyte file, like that can't get anywhere near this device usually, right? Like the SD card might be able to handle it, but like to do any searches or to do anything on a data set that big on a device like this, it's just purely impossible. But with binary quantization, it is possible. We can, with trading off accuracy and trading off some like timeliness like this, we are able to run something that's meant for large servers, Mac OS devices on something much smaller like this little Raspberry Pi device that we have here. And theoretically, this could also run on Android and iOS devices. We could take that same SQLite database file, transfer it over to Android or iOS, have that accessible through to our applications, and it should theoretically run there. I just haven't tried it because mobile device development is just something completely foreign to me. But it should be possible as well. And you could theoretically also do it in WebAssembly. So you should be able to attach a 500 megabyte file within WebAssembly. It'd probably be a little bit slow and it'd probably use a lot of RAM, but it's still possible. Like it's still possible to use that same exact file, do the same exact embedding, same exact KNN searches, and get similar results using in WebAssembly on the command line, on mobile devices, and on here as well. So that's binary quantization. And one more shout out that one more thing I want to talk about binary quantization is that different embeddings models have different levels of support for binary quantization. I would say that specifically, let me go over to here and then change over to Chrome. I would say for embeddings models that support binary quantization, the best blog post that I've seen about this is from Mixed Bread AI. They have their own embeddings model that's, I think it's around like a gigabyte or 2 gigabytes of size for the embeddings models itself, and it outputs 1024 dimensional vectors. It's a pretty good text embeddings model. It's all open source. You're able to run it yourself if you want to. And they also have a hosted, paid version of it if you're really interested in that. But what Mixedbread, this blog post by Mixedbread talks about how well their model performs through binary quantization. And specifically, this table is probably the best table that I've seen that talks about this kind of stuff. So here we can see that the full floating point. So this is a full vector that is outputted from this Mixedbread AI model is 4,096 bytes, or around 4 kilobytes. If you perform binary quantization on that, then you get down to 128 bytes. So again, a 32% reduction. Now to see how well that performs in terms of accuracy, if you view the floating point results as 100% accurate, then after binary quantization, it'll be 96% accurate. All right, so that is, you're losing 32% space. You're going from 32 bits of precision down to 1, but you could still retain 96% accuracy with Mixedbread's model, according to them and according to the benchmarks that they have. You could also do further reductions if you really want. So for example, what you could also do is lop off half of the embeddings. So just keep the first 512 instead of looking at the full 1024. You could lop off half of them and then do binary quantization again, and you still have 90% accurate results compared to before. Now that if you do binary quantization and only look at the first half, that is a 64% reduction, or 64 times reduction in space instead of 32. So again, you're losing, you would think you would lose a lot of accuracy, but depending on the embeddings models and what they support, you may not be losing a lot of accuracy at all. You might be able to retain 90 or 95% accuracy with certain embeddings models. Now, not all embeddings models specifically support binary quantization. I think it just kind of works out of the box most of the time because most embeddings models have numbers that output between -1 and 1. So most of the time it should work just fine. But it's nice to have embeddings models that specifically train on that, so that way you can rely on it a little bit more. I'd say from like trying it out myself, I usually get like 90-ish% accuracy from other models that I've tested out. So trying it out in OpenAI's model and a few other ones, that's typically what I see. And that's usually good enough for most RAG applications or semantic search applications to reduce the amount of resources that you need and still have like good enough performance or good enough accuracy. And it all runs on sqlite-vec. Again, to reuse this in SQLite-vec, it is usually a single SQL function that you have to call in order to reduce a floating point vector into a bit vector, and it's good enough most of the time, and it's quite fun to see, and much easier to play with large data sets using binary quantization that, again, will also run on Android devices, Raspberry Pis, iPhones, and everything else. So yeah, that's all I had for today. So mobile device support and binary quantization. Happy to answer any questions that you have, whether it's about like specific code samples or anything else. Again, I might not be able to hear, so if you could put something in the chat, that'd be great. But if you want to come on stage and say it, as long as someone can transcribe it in the comments, I would greatly appreciate it. Happy to go over any code as well. I would say again, let me drop a link to the Google Doc again, if you're interested in that. So just dropped a link in the chat to the Google Doc for this event that has links to all the projects that I talked about. So if you want to take a look at OP SQLite and how SQLite-vec is inside there for running SQLite-vec in React Native on Android and iOS devices, a link to that is there. I have a few tips for binary quantization in there as well, including the notebook that I had that converted that large 15 gigabyte data set into a much more manageable 600 megabyte data set. A link to that notebook as well. And happy to answer any questions that you have here. I'd say in general, if you are here, that means you're in the Mozilla AI Discord. Please join it if you haven't already. Go ahead and join the. If you're asked to choose a role, choose the SQLite-vec role, so that way you get updates whenever there are updates to the SQLite-vec project. And I'm always happy to answer any questions that come up inside of that channel. So if you have any specific issues about SQLite-vec, or you just want to talk about like vector search or embeddings models in general, happy to do so in that channel. And if you have any questions, I will be happy to answer them in this chat. I can stick around for a few more minutes. One question, does this work with Nomic embeddings? I believe so. On Twitter, some of the engineers at Nomic have mentioned that they specifically trained on binary quantization loss. Although I haven't seen that specifically in their documentation. I've only seen it on Twitter from engineers, so I'm pretty sure it's still good. I haven't seen any specific numbers on how accuracy holds up for binary quantization, similar to how Mixed Bread published that table of like how accurate they were after they do binary quantization and everything. But I believe Nomic should still work. I'd say in general, if your embeddings model is above like 1,000 dimensions, which Nomic is 1,024, that's usually a big enough space for binary quantization to work. Since that's 1,024 bits of on and off switches that you have to like kind of create your own space there, I'd say in general, like it's good enough for when that happens. Or when you have vectors with dimensions that large. It probably works with smaller dimensions as well, but like if it's above 1,000, like it usually do pretty well. It also matters like how many vectors you have in your index. If you have like 10 million embedded, if you have like a vector index with 10 million vectors and you only have like 1,000 bits of like precision to search through 10 million embeddings, it may not be enough. But like if your data set is small enough, it's probably good enough. One thing I do also want to mention is that I will eventually add support to have custom thresholds for binary quantization. So like I talked about before, the threshold for normal binary quantization is 0. So if it's above 0, if it's positive, then it's a 1. And if it's below 0 and negative, then it's 0. That is a base threshold that like most people have, but you are able to, there is one approach where instead of having that threshold at 0 all the time, you can instead have if you already have a pre-existing vector data set, and you want to have a different type of threshold to kind of like not fine tune it, but have a better threshold that fit your data. What you could do is for all the vectors in your data set, you could take the mean or the average of every single element in every single element in every single vector, take an average of all those, and then use that as a threshold. So instead of 0, it might be 0.15 or negative 0.76. It will depend on your data, right? But that should give way better binary quantization results than just having a general 0 thing. So it's not fine-tuning, it's not that complicated, and it doesn't require that much CPU usage, but I think it would improve accuracy if you had a pre-existing vector data set that you're searching through, right? So if you have like a semantic search engine of newspaper headlines in the past 200 years, you could probably do that trick, that binary quantization trick where you take averages there and choose a custom threshold from that. That'd probably work much better in applications like that. It's not supported in SQLite-vec yet. I will add an SQL aggregate method for taking the average of floating point vectors, which should help with that, where you can choose a custom threshold. So that should be coming soon. And when it does, I will, there'll be a GitHub release for it. I'll talk about it in the Discord channel. So stay tuned for when that happens. Oh, another question: is there a way to run vector search across multiple SQLite files without running separate queries on each and then combining it? Not that I know of. You could probably do you might be able to attach other SQLite databases using the attach database SQL command, and then do a union all between all of them. I don't know if it would run all those queries in parallel. I would say if you do have multiple SQLite files and you're trying to combine the results like that, let me know what you're trying to do, because if you're just trying to if you just have different vector indexes and you want to have a parallel query thing, I might try to support something that could perform that better within SQLite-vec itself, or maybe there's a different architectural approach you could take that better supports that works better in SQLite applications. So happy to hear more about what you're trying to do there. But yes, I can. Yeah. Mhm. Yeah. Mhm. Mhm. Yeah. Yeah. Mhm. Yeah. Yeah. No, that's cool, and thank you for explaining. I would say that since SQLite-vec runs in process, I don't know how much performance benefit you would get if you had in the same process multiple threads that were reading it from a SQLite database and combining it like that. I don't know how much the performance would improve there. If they were separate processes or possibly separate threads, it might work better. I haven't seen it tried out too much, but I know that the Feist vector library had a sample application where you could very similar have different shards or different workers that have their own Feist vector index, and then it was a way to combine all those and have one query hit all those workers and then get all the results back from all the workers and then condense it after that. So I know there is some prior art in the vector search space for supporting something like that, but it's not supported in SQLite-vec yet. And SQLite-vec or SQLite in general might make it a little bit harder since it's in process and takes up the thread. But I'm sure it's possible in some cases. I would say that if you just have again, I don't know what your setup is like, but if you just have a straight up one web server per worker, maybe that could help in some cases as well. Yeah, I'm sure there's a way to go about it, but yeah, for sure. Yeah, yeah, I'm down for sure. One question about full text search and vector search. Great opportunity to say that the next SQLite-vec event will be about hybrid search. So one common use case for vector search is for kind of a fuzzy vibe search across text data, and SQLite already has a good built-in tools for full text search. So you can combine the two fairly easily. It's called hybrid search. It works with SQLite-vec. I just haven't documented it. But the next Discord Mozilla AI event that we will have for SQLite-vec will be about that approach specifically. I will have a blog post and a documentation page about that before the event happens, which will probably be in the next 3 to 4 weeks. But it is possible, and happy to talk to you about it if you are curious about that before next time. But yeah. Cool. So in that case, we are at time. Again, I am happy to answer any questions you have at any time in the Mozilla AI Discord, specifically inside the SQLite-vec channel. I will also drop a link to the Google Doc with all the links to all the different projects and stuff that we talked about in that channel in the next few minutes. And once the recording is available and up on YouTube, I will also ping people on there in that channel when that's ready. So yeah, again, next event happening in the next 3 to 4 weeks. It'll be about hybrid search, so combining vector search and full text search. And we should be good from there. Jans, I know you wanted to talk after this. I will end this event and then go ahead and message me on Discord, and then we could chat on there. So happy to do that separately outside of this stage. So again, thank you all so much. Thank you, appreciate it. Again, hit me up on Discord anytime you want inside the Mozilla AI server. So see you all later. Thank you again.